The other day I had a question about a holding circuit. A holding circuit. Well, before we talk about a holding circuit, we need to make sure we understand what a circuit is. We said a circuit is having your power supply, having a conductor, then your switch, and in this case we're going to have, let's say, 2 and 3 switches. Then we have the load, and it goes back to wherever it came from. So I have your power supply, your conductor, switch, and a load. So what we're going to do here is we're going to have this as a temperature switch. We're going to have this as a pressure switch, and then another pressure switch right here. So this is going to be a little bit different, because on this one, this is going to be a temperature switch for the compressor. A temperature switch for the compressor. So in other words, when the compressor gets too hot, this will open up. And the compressor will not run because it's going to shut off the compressor contactor coil. This gets too hot, compressor contactor coil shuts off, and the compressor is not going to run. This right here, well, this is going to be our low pressure switch. This one is going to be our high pressure switch. So now, compressor gets too hot, this shuts off. Pressure gets too low, this shuts off. Pressure gets too high, that shuts off. So it sounds pretty simple, not much to this. But now, we talked about a holding circuit. With a holding circuit, it's a little different because we have these switches. Now we're going to need, for the holding circuit, we're going to need another line coming this way, and it's going to go down to another coil, and that's going to be my lockout relay. We're going to come from there, and we're going to go up to here. So now power comes in here, goes through this switch, through this switch, through this switch, energizes this. This relay is not energized right now. This relay, because this switch is closed, this switch is closed, and that switch is closed. When this temperature switch opens up, then power can no longer go this way, and it always wants to go to where it came from. It's going to come through here, go through this lockout relay coil, and use this one and this as a conductor, and it's going to go back to where it came from. Now, you may be asking yourself, how come when all of these are closed, this and this will not energize at the same time? Very simple. This relay is a special relay. It has to have higher impedance. It has to have higher impedance. What that means is that now it has to have higher total resistance. Total resistance. Now, on Ohm's law, we can figure out what the amperage is, what the voltage is, and resistance and all of that. Well, Ohm's law does not work on inductive loads. This is an inductive load. It does not work on inductive loads because when you have an inductive load, amperage goes up, and then as the magnetic field builds up, it fights the electrons, it holds them back, and then your amperage drops. If you've ever noticed on motors, you have that inrush current, and then it drops. It drops as the motor speeds up. As the motor speeds up, it's building what they call a counter electromotive force. And this can get very complicated, and I don't want to get into too much of this. But this relay is going to have a higher total resistance than the coil. Because of that, when this opens, this will energize and is going to use this as a conductor and this as a conductor. Now, we're missing one piece. So let me erase this, and I have a set of contacts right here. These are going to be lockout relay contacts. So when this energizes, these will open up. Once these open up, Once that opens up, this closes back. It can't go through here because that's open. It still goes through here, uses this as the conductor, it goes back to where it came from. This is closed, and that's open. Now the only way to reset the whole thing is to turn the main power off. You turn the main power off, these go back to the closed position. This is closed, and this is closed, and that's closed. I mean, that's your coil, energizes the coil. So now this stays unenergized because this has less resistance or less impedance than this. And it all works. As soon as the low pressure switch opens up, once that opens up, then power cannot go through, travels through here, energizes this, opening this up, and now is using this as a conductor to go back home. When the low pressure switch closes, that stays closed. That stays open. Once that stays open, this stays energized, it's not going to run. You have to come back, turn power off, turn power back on, you reset this, it works. Your high pressure switch is going to be manually reset. So now you have to come in and actually push a button to restart it for the compressor to run. So we have this switch and this switch in the circuit. When any switch that is in series within the holding circuit opens, the lockout relay will energize, opening up these contacts, making sure the compressor does not come back on. So this is your holding circuit, this is your lockout circuit. When any of these switches that are in here open up, their lockout relay will open up, will energize, opening this up. On here we could have several other switches. So when any switch here opens up, the compressor will be locked out until you turn power off and turn power back on. I hope this helped. Again, this is Julio from Aircon Academy.